Welcome to another class in system programming. So today's topic is going to be sudo op and machine op. The instructions basically can be classified into two different types. One is called as a sudo op and the other one is called as the machine op. Here op means operations or your instructions. Right. So what do you mean by a sudo op? Okay, pseudo ops are not going to be executed, they are going to be information to your assembler. So the pseudo ops are used to only provide information to your assembler. Okay, the machine ops or the instructions which we have seen normally, whatever instructions we see, all the instructions are going to come under the machine ops, but pseudo ops are instructions only for the assembler. Pseudo-ops. Pseudo-ops are also known as assembler directives. So because it gives the direction to the assembler or information is provided to the assembler, that's why pseudo-ops are known as assembler directives. So you should remember this term, whether it is asked as pseudo-op or it is going to be a question is going to be as assembler directives, it has to be these pseudo-ops only. So we are going to see the pseudo-ops here. There's a list of pseudo-ops. So let us start with the first one. First pseudo-op is called as start. Okay, start is going to indicate that the program is going to begin. Start of the program is going to be indicated to the assembler using this particular keyword called start. It is a pseudo op, right? Pseudo op tells the assembler where the beginning of the program is and allows the user to give a name. Okay, the second use of this start instruction is you can also give a name, you can also name a program. Okay, so if you want to give a name to the program, that can be done with this start. Okay, so how do we do that? So the syntax is going to be like this: test start. For example, here test is the name of your program, start is nothing but your sudo op. Okay, it says the program is going to begin, so this will be the first line. So how much of memory will this occupy? This is a sudo op. Sudo ops will not occupy any memory because it's not going to be not going to be executed. It is only an information for your assembler. Okay, so you should remember that other instructions we have seen different instruction formats. I said rs, rx, ss, rr and all. So each one we know how much of memory they will occupy, but here we are not going to talk about how much memory they're going to occupy because they're all pseudo ops. They just give information, they are not for execution, right? So whenever we say there is a start, there also should be an end to the program. So end is going to tell the assembler that the program has ended, we have reached the end of the program. Okay, so let me repeat. So we are actually discussing about pseudo ops, right? The first pseudo op is start. Okay, start pseudo op is used for two purposes. First purpose is to indicate that the program is going to start. The second purpose is to give a name to the program. Second one is end. End just has syntax is end only. It just tells the assembler that the program has come to an end. Yes, next one. Here, using is a pseudo op again. So I told you it is going to pseudo ops are going to give information to the assembler. Just see how relevant that is. Using is going to tell the assembler what is the base register value. Okay. So why should we know the base register value? Whenever I am loading a program into the main memory, that address, the starting first line's address is going to be your, what address is that? Is going to be your base register value. That address will be stored in your base register value, so that you have to find the absolute address. So you only will know the relative address until you load it in the main memory. Once you load it in the main memory, you have to add the relative address, index register value and the base register value. Here the base register value is nothing but the address which is given to you in the main memory, the starting address where you are going to load your program. How will you say give that pass that information to the assembler? Is by using the pseudo op called using. Okay, using is going to actually tell you two things. Using will actually give you two information, give the assembler two information. The first information it is going to give is, for example, let us take the start with the example. Using star comma 15 is here. Okay, here this instruction tells the assembler that 15 is going to be the base register. Okay, we have registers r0 to 0 to 15, we have 16 registers, of which register 15 is what I'm going to use as a base register. That is the information we are giving using this command. Using command says 15 is the base register. Okay, and what is the starting address, what is the contents of the base register? What should be the contents? After I load it to the main memory, that address has to be the contents. So what do you mean by star is, star says the current address. So whatever is the current address, that is going to be the value which has to be stored in the where base register 15, right? So when will I use this using command? So I will use this using command right before I begin my first instruction. Before beginning my first instruction, I will use this command using, so that the current, wherever the current position of my cursor is in the main memory, will be the actual address which has to be stored inside my base register, right? So that is the trick here. We will also see an example program where you will understand it. Using sudo op says two information, gives you two information. First information is which is the base register. Okay. Second information is what is the contents of the base register. These are the two things. So the example we are seeing here, using asterisk. Wherever you use asterisk, it means the current address, right? Where the location counter is pointing to, right? The next one is nothing but 15 is your base register value. Let us see the next example using begin plus 2. Okay, using begin plus 2. So what I mean by begin plus 2 here is, begin is a label. So usually this label is going to point to the beginning of the program. Okay, it is going to point to the beginning of the program. So we are going to say begin plus 2 means just leave two locations and that will be the starting. So asterisk will say current location is the starting location. For some purpose we are saying begin plus 2, which means starting plus 2. We are going to leave 2 bytes and then say that will be the contents of your what base register 15. So that is your second example, right? Yes, so this is using. So just remember, you can always use a simpler example. So using asterisk comma 15 is one example which you can write, right? Next one is drop. Since I have used already, I'm using register 15 as a base register, I cannot use register 15 for any other purpose. So what I should say, that register is unavailable is what I should say. How will I say that? I have to use a drop sudo op to say that. So drop 15 here means register 15 is unavailable for use. So that is your drop sudo op. The next sudo op here, you have ds and dc. So what I mean by ds is, it is defined storage. Dc is defined constant. So what is the difference? Let us see. Defined storage is used whenever you declare a variable. What happens? Say for example, I say int a. Okay, let us say in C programming, int is going to be of 2 bytes. So when I say int a will be a variable which is declared, which will have, or which will be allotted with 2 bytes of memory. That's what happens. So 2 bytes of memory will be allotted to the variable a. Same way here, block is the variable name. So look at the example. Block is the variable name. ds defines storage and it says how much bytes I wanted to allot for this particular variable block. Okay, so there we said int. So here you don't have anything like int and all. So here what are we going to say? We are going to say exactly the size of that particular variable that is required to be allotted. So define storage, I am defining the storage space for my variable, right? I'm defining the storage space for my variable. It is exactly like your int a. Similarly, we are going to say block define storage and we are going to say how much of memory we need. Yes, how much of memory we need it, I'm going to here I'm saying 5f. What does that mean? Okay, so when we studied the general machine structure, I told you the word size here is what, 4 bytes. Okay, 32 bits or 4 bytes is the word size of this particular IBM 360. So I'm saying I want 5 full words. Okay, I want 5 full word. F here, 5f here means 5 full word. So word can be full word, which means 32 bits. It could be half word, which is 16 bits, right? So I want 5 full words, which means I want 5 32 bits. So or in other words, I can say I want 5 what, one word, 5 one words. So 5 into 4 bytes. So I will be needing 20 bytes for what? To store this particular variable or to store value in this particular variable block. I need 20 bytes. Yes, that is the meaning of it. So I repeat that. What is 5f? 5 says how many full words you want. So what do you mean by full word? One full word here is 32 bits or 4 bytes. So I want 5 4 bytes. So I actually want 20 bytes where I can store the value for this variable block. So the variable name here is block. ds is the keyword I use for defining the storage and 5f is the amount of storage I require. Yes. Next one is dc. This is define constant. So in C programming, int a, what will it do? It will only declare a variable and then it will also allot a storage space. Int a is equal to 10. What happens? It will declare a variable. It will also what? Allot a storage space and also store a constant value inside it. Yes, also will store 10 inside a. Okay, that's what is going to happen here. Here dc, define constant, it does two things. One, first of all, it will allot a space for that particular variable and also assign a value inside it. It's going to also assign a value to that particular variable. Yes, let us see one example. For four is a variable name. DC, define constant. 1f, I only want one full word, which means how many bytes? 4 bytes. Okay, and what is the value I want to store inside that? Will be given in single quotes, that is 4. So what I am doing here, I am declaring a variable named 4 and I am storing 4 inside, number 4 inside that variable. Yes, so this is going to be something similar to int a is equal to 10. You understand? So there are two more pseudo ops. So one is called define storage, other one is called define constant. So define storage only will allot the storage space. So define constant will allot the storage space and also store a constant inside that particular variable. Okay. So one more thing you have to remember here, variables, we don't call them as variables, we call them as symbols. Okay. We are going to call them as symbols. Is what you should remember. They're all called as symbols. And the constants like 4, these constants are known as literals. So these are the two terms I wanted to introduce you now, so that will be helpful for you in the future, right? So all the variables here are, we are going to call them as symbols, and all the constant values we are going to call them as literals. Symbols and literals, right? Yes, next. So there is the other pseudo op called LTORG. It means organize the literals. Okay, organize the literals. What do you mean by that is, whenever I'm writing the program, first I will write my program and then there comes the data part. Storing the data happens later. So what happens? What is that I'm going to do now? I will first store the program and then comes the literals. Okay, literals or values which I'm going to use in the program will be defined in the later part of the program. So whenever I say LTORG, what happens? Your assembler makes sure that the literals or the values which are going to use, data you're going to use for the program, follows right after the program itself. So it doesn't have to say store something else. It should not store something else in between and then give the data. So you're saying I want the data to be stored right after the program. Sudo op tells this sudo op tells the assembler to place the encountered literals at the earlier location. Okay, so as soon as we finish the program, earliest location, we are asking for the literals to be stored. It's called literal organizing or LTORG. Next comes EQU. So EQU is used to define variables. Okay, say for example we use define command. Yes, so in define we used to define some constant values in C. Similarly here we have something called as EQU, right? BASE is the variable name or a symbol. BASE, base equal to 15, the meaning of it. Base equal to 15. So whenever I come across BASE variable inside my program, always that value will be substituted by 15. Right, it is going to be substituted by 15. So we are going to have EQU, which is going to define a variable or also store a constant inside that variable. Example, BASE EQU 15 is the syntax. So you have to have the variable name EQU and the value which is going to be stored inside that particular variable. Here 15 is a value. It's not a register number or anything else. It is going to be the value that is going to be stored or a constant that is going to be stored inside this base. Right. So far what have we discussed? Let me again one more time we will go through it. The first thing is we are discussing pseudo ops. Pseudo ops are also known as assembler directives. It is going to give you an instruction or an information to the assembler. It's used to give some information to the assembler. It's not for the execution purpose. It is for the information to the assembler. First one is start. It is you're going to tell you where the program begins. You can also give the program name there. The second one is end. It tells you where the program ends. So third one is using. Using tells two things, which is your base register and what is the value stored inside the base register. Drop tells you which register is unavailable. DS is going to define the storage. DC is going to define the storage and also store a constant inside it. So to store a value inside it. LTORG, literal organize. So as soon as you encounter a literal, you are asking the assembler to place it at the earliest location, which means soon after the program. EQU here, EQU here is used to define a variable, define a constant inside a variable value. So EQU is used wherever you have to have a constant definition, right? For example, BASC EQU 15 here means BASC equal to 15. So wherever there is BASC, it will all be substituted by 15 in the throughout the program. So these are the some of the pseudo ops here we have discussed. Yes, we are done with the pseudo ops. So next comes machine op. So machine op, already we have seen a lot of instructions already. Add, load, store. Okay. So apart from that, we are also going to list some of the instructions which we will be needing for the programs. So actually pseudo ops are only the ones which we have seen already. Machine ops, all the ops whichever comes under the instruction format category RR, SS, RX, RS. Okay. All these are going to be machine ops only. Okay, so we are going to just list three. So it is always better for you if a machine op is asked, write these three, because this will be actually present in the key, right? So it's always first write this, then you can write your own instructions also. You can continue with that. Yes, the first here, the three instructions we are going to see are all going to be branch instructions. Let us see, the first branch instruction is BALR. So what does this means? Branch and link. Branch and link. This instruction is similar to the using instruction. Only thing is using is a opcode, or an, I'm sorry, using is a pseudo op, and this BALR is a machine op. That's the difference here. So what are you going to say here is, I'm going to say first branch and link. So first linking will happen. BALR, here see the example, BALR 15 here means 15 is going to be your base register. The address present in the next line. Okay, the next address line, whatever is there in the next line, that becomes your value for the base register, or the address which is going to be stored inside the base register. I will repeat here, BALR, branch and link. First I'm linking, I'm saying 15 is the base register, and I'm saying the address which is pointed by the next instruction will be the value stored inside my base register, right? I have linked, I have said this is the base register, this will be the address stored inside the base register. And then immediately what I wanted to do is, I also wanted to branch. I will say this is the base register, and I will branch to the address whichever is pointed by my second operand. Whatever my second operand says here, there I will, that address will be the address where I will branch to, right? For example, BALR 15 comma 0 here means 15 is the base register value which will be loaded with the next in address, and after I finish that loading, I have to transfer my control to the address location 0, is what it says. You can say any address there, whichever address you wanted to branch. So it's a branch, it does some work and then it will branch. What is the work it does? It is assigning the address to the base register, right? BR, it is an unconditional branch. So what is unconditional branch? You just branch to some address location, that's it. For example, BR 14, so it has to just unconditionally branch to the address location 14, that's it. So there is no other condition checked here, it is unconditionally branching. The previous one also actually is unconditionally branching, but the one operation it does is, it is going to say which is the base register and what is the value inside the base register. It says that and then it branches. BR, without any giving any information, it just branches. Yes, the next machine op is BCT, branch on count. This is very similar to the looping we do in other programming languages. BCT, branch on count, right? First look at the example so that you will understand it easily. BCT, I'm going to say 3 comma loop. Okay, so 3 here is a register. So what happens whenever I execute this? Register 3 will be decremented by 1. Say for example, I wanted to loop a particular program 10 times. So I will store 10 inside my register 3. Register 3 will be stored as 10. Okay. So every time I come to this BCT command, it will be decremented by 1. Okay, so 10 will be decremented by 1, it becomes 9. It is a positive number. If it is a positive number, it will loop, it will go to the first line, again it will execute all the lines and come back to BCT. Again it will decrement by 1, so it becomes 8. So it is a positive number, so it goes back and loops. Similarly, it keeps decrementing until it is a positive number. Once it is a negative number, Okay, once it is going to be -1, it has to break the loop and come out of the loop, right? So BCT is branch on count. You are going to load a number in the particular register. In this case, it is register 3, and we are going to say looping. Loop here is a label, which means you are saying go to that particular label, wherever that label is, go to that particular line and keep looping until your register 3 is positive. If the register 3 is a negative number, you have to break the loop and come out, right? So I will read it. This command decrements the given register by 1, and if the result is positive, branches to the address in the second field. If the result is negative, it breaks the loops and comes out of the loop. Okay, so these three are the machine ops which we are going to discuss in this particular chapter, right? So you have BALR, BR, and BCT. BALR is branch and link, BR is unconditional branch, BCT is branch on count. Yes, we will see an example program now, right? So what do we have here is the same program which we already saw. So the program here is nothing but, so you have to add number 49 to 10 different data. Okay, but this is the actual program which is complete. Okay, we only studied the instructions in the previous sessions. We saw some uh, different types of writing the same program, and then we saw some of the instructions which we used for it. Okay, if you see, it is the same program, but actually this is how it is written. So it's a complete program. So again I will explain it to you. Just look at this. We used SR 4 minus 4, subtract here 4 minus 4. We cleared register 4. Yes, it is the same instruction. Just look into the next one. We said L3 comma, if you remember, we said 904. Yes or no? We said 904 there. So we picked up one number from 904. We picked up some number from location 900, some number from location 896, and so on. So we did all those things, right? Yes, you remember. Similarly, instead of giving the relative address, what are we going to use here is we are going to use symbols. So just now I told you there is something called symbols and literals. Symbols are using your variables, and literals are how do you use your constants. They are nothing but constant values, right? So here variables which we are going to use here, say for example 10 is a variable. Okay, what is the variable 10 going to store? Let us see here. The variable 10, can you see that here? The variable 10 is going to be of size one full word. Just f means one full word. If you say 2f, which means two full words, just f simply means a one full word it is. Okay, 10 is a variable name which is of size one full word, and the value stored inside 10 is nothing but 10 itself. So to make it easy, we are giving the variable name also same as the value which is present inside. It's going to be the same value. So 10 here is a variable name, ten is a variable name, and 10 is stored inside that. Okay, why am I using 10? Because I want this loop to be executed how many times? 10 times. So what I will do, I will load 10 into which register? I will be loading 10 into register 3. Okay, and I will be decrementing register 3 here in this line. Okay, and then looping is here, loop is here, right? You have to keep going to this particular line and execute the whole thing, right? So first thing what I did, I cleared register 4. Next thing is I'm loading 10 into register 3. Why? Because I'm going to use a loop and I'm going to decrement 10 until it becomes 0 and then come out of the loop. Okay, so loop starts from address location 8. Loop starts here from address location 8 because I want these commands to be looped, put in loop, right? The next command, let us see what it is. Load 2 comma data of 4. Okay, what does that means? Here data is nothing but the numbers which we started storing from location 904. You remember 904, 908, and so on. So that is what we are doing here. Data here is nothing but it is going to be starting, you're going to start to store it at, say for example, location 904, right? And it is saying one full word. First data is going to be 1, the value is 1, it is going to be stored inside one full word. Similarly, this is the second data, third data, fourth data, fifth data, sixth data, 7, 8, 9, and 10. So there are 10 numbers consecutively stored. Each one is going to occupy one full word, which means 4 bytes, and we are going to store it one after the other. So what it becomes? It becomes something like data of 1, like an array, data of 2, data of 3, and data of 4, like that. So we cannot say data of 1, data of 2. Instead, we will be saying data of 0, data of 4, data of 8, data of 12. Why? Because that is going to be the address which you have to add. Say for example, at location 42, I am storing data. Okay, which means the first number will be stored at location 42. The second number will be stored, which is 3. 3 is the second number, that is going to be stored at the location 46. Third number is going to be stored at the location 50, 54, 58, and so on. You understand? So that is how we are going to store this data, right? Next one is add 2 comma. So we are, wherever we had address, we are replacing with variable name. That's all we are doing here. Wherever we had address format, we are going to replace it with what? With variable names. 49, FORTY 9 is a variable name. What is it going to store? Obviously it's going to store the number 49, right? I'm going to say add the contents of register 49 to with register 2. So that's what the add instruction, same instruction which we saw. If you keep both the programs next to each other and see, you will definitely understand it very clearly. Next one is store 2 comma data of 4. So data of 4 here means 4 here is nothing but your index register. So index register we are going to use is register 4. So whatever value is there in register 4, that is what you are going to here specify. So you are going to say data of 4 of the index register, right? So how will I pass the values to the index register, or how will I increment the value? I'm going to use add instruction 4 comma 4. Register 4 has to be whatever value is present in FOUR has to be added with register 4. FOUR will contain 4. So every time I will add 4 to my index register. So index register in the beginning will be 0, then it will become 4, then it will become 8, then it will become 12, and so on. Right? The last one is the loop instruction, of course. Okay, it will loop. Once looping is done 10 times, you have finished adding 49 with all the 10 numbers. So you will come here, the loop, it will become, the register 3 will be 0 last time, and after that when you decrement it, it will become -1. The loop will end there. You come to the next line, you say branch to 14. So what I mean by that is, so you have finished, your program is finished, you are branching to some other location, unconditionally branching to some other location, which because your program is over, right? Yes. So here you can see the data here. So all these are data. So whenever we are actually accessing them, then that time the cursor will come here, take the value and go back, and then do the manipulations in the program. So what are the data stored? Right, so these are all the data. 10 is a variable, 4 is a variable, 49 is a variable, data is a variable. All are going to be of size 1 full word, which is 4 bytes. Okay, which is 4 bytes. So what are the new commands here? So the one new command is bct, so branch on count. Br, unconditional looping. Dc is define constant. So these are the new commands which we, whatever we have studied in the previous slides, we are trying to use it here, right? This is the program. Again, what else is there? Again, you can see there is a sudo op called start, and there is a test is going to be the name of the program. So whenever I have start, I will also give the name. So one more thing you observe here, you can see that the start, and after the start you're going to use BALR. So this is the usual format here. If you see this, this is the format. I will start the program. I have to say BALR and also give which is the base register and what is the address for the base register. I should say that. Okay, so here I'm going to say 15 is the base register and 0. Okay, it's going to be the, I'm going to flow of program is going to go to this particular line, and it is going to start the execution, right? It is going to start for the execution from this line. So what I'm saying is 15 is the base register, and it stores the what next instructions address in 15. What is the next instruction? This is going to be the next instructions address, right? Similarly, we are also using a sudo op. This is only for information to the assembler. So what is that? Using begin plus 2. Begin is 0, plus 2 will be this line. That will be the contents of the base register is what we are saying. Begin plus 2. Begin is this one, plus 2 will become here. Okay, because BALR is a RR type instruction, it is going to occupy 2 bytes. So that's why it starts with 0 and the next instruction will be at location 2. Okay, so don't confuse yourself too much. Just you roughly you understand this program, it is more than enough. You have to understand what is a command, what is that, what is it doing, right? How are variables declared? Okay, so what is the use of BALR and using? So if you understand so much, it is more than enough, right? Yes.